Alright, welcome to the last practice exam video. So we had a large mixing tank, contains 100 gallons of water, 20 pounds have already been dissolved. So let's draw a little tank. So we got 100 gallons, and then we got 20 pounds of salt in there already. We're pumping in a mixture at 5 gallons per minute, and it has 5 pounds of salt per gallon. And then we are pumping out 4 gallons per minute after mixing the solution. So we can say that dAdt, the rate at which, I should say what A is. So we're setting up an initial value problem that models this scenario. So let's call A the amount of pounds of salt after t minutes. Then how quickly is the amount of salt changing here? Well, we can compute the rate at which the salt is being added to the tank minus the rate at which the salt is leaving the tank. The rate at which is going into the tank is pretty easy because it's just, you have 5 pounds per gallon being pumped in at a rate of 5 gallons per minute, right? So that's going to be just 5 pounds of salt per minute minus, well, how much salt is leaving. So we're taking this mixture and then pumping it out at a rate of 4 gallons per minute. So we need to figure out how much salt is in the tank at time t. So it starts off with 20, right? But that's changing over time. So A is going to be I misspoke a little bit. So A is the amount of salt at time t. We're interested in the concentration of salt in this mixture, right? So how many pounds of salt per gallon do we have? Well, we have A pounds of salt total divided by how many gallons are in the tank at time t. So it starts off at 100, right? Starts off at 100 gallons, but we're pumping in 5 pounds per, pumping in 5 gallons every minute and pumping out 4 gallons every minute. So 5 gallons go in, 4 gallons go out. Every minute, that's a net change of 1 gallon. So starts at 100, and then after t minutes, the number of gallons has increased by 1 times t. And so we get dAdt is equal to 25 minus 4a over 100 plus t. In part B, we have a similar looking differential equation. It's not exactly equal, and we just have to solve this. And let's, might as well do this using the integrating factor method. That's just what I feel like doing. So I'll bring this term to the left-hand side and then leave the 6 over there. My integrating factor mu is going to be e to the integral of, or p of t over here. This is with respect to t. So this is really like mu of t, not like mu of x like we used a lot earlier in the semester. So e to the ln of 100 plus t, which is just equal to 100 plus t. And I'm going to restrict our domain and just say this is equal to 100 plus t. So multiply by the integrating factor on both sides. We get 100 plus t times dAdt plus 100 plus t over 100 plus t times a of t. This is equal to 6 times 100 plus t, so 600 plus 6t. Left-hand side should be equal to d dt of 100 plus t times a of t. And we should always check that. So if I do the derivative of this, derivative of 100 plus t is just 1. Derivative of a of t is literally just dA dt. So by the product rule, I should get dA dt times this plus 1 times this, which we do. So now we can just integrate both sides with respect to t. And on the left, we just get 100 plus t times a of t. On the right, we get 600t plus 3t squared plus c. We don't know what c is yet, but we can solve for a quite easily by dividing over. And you get this. We need a of 0 to equal 12. So 12 should be equal to, just plug a 0 into everywhere. So 0 plus c over 100 plus 0. So this is really just c over 100. So c should be equal to 12 times 100, or 1200. So a of t should equal 3t squared plus 600t plus 1200. I'm just cleaning up the top a little bit, over t plus 100. All right, autonomous first order differential equation. Find the critical points and draw the phase line diagram. Let's factor this. I'll factor out a negative y. I get y squared minus 7y plus 10. How does that factor? That factors as y minus 2, y minus 5. So critical points are y equals 0, 2, and 5. Phase line diagram. Let's put those critical points down here, 0, 2, and 5. Just need to figure out if this is if y prime is positive or negative on each of these 4 intervals. So if I plug in if I plug in like negative 1 over here, so if I plug negative 1 into this, I'll get positive 1 times negative 3 positive times negative times negative. So I should get positive. So it's going to be going up between 0 and 2. If I plug in 1, I get negative 1 times 1 minus 2 is negative 1 times negative 4. So that's going to be negative. So it's going up. If I plug in 3, I get negative 3 times 1 times negative 2. So I would get positive. And if I plug in 6, I would get negative 6 times 4 times 1. So that's negative, so that's going down. All right. So if we want to sketch some solutions for the following initial conditions, so 0, 2, 5 here. Okay, so we are going to plot these points. So here's going to be 0, negative 2. Here's going to be 0, 4. Here's going to be 0, 1. And here's going to be 0, 7. So we basically just want to take this information up here. So it's going upwards below 0, so it should look something like this. It's going downwards, sloping downwards at -1, or sorry, +1. So that should look something like this. And maybe I should draw a dotted line over here. Put one up here as well. At 4, it'll be similar. It's sloping upwards here, and then it's sloping downwards at 7, so it should be something like this. And classify each critical point as a attractor, repeller, or node, or whatever you want to call them. Just going to bring this down here. This is easy to see. So this is an attractor. This is a repeller. And this is an attractor. Also sometimes call this stable. This guy would be unstable. This guy would be stable. If you had something that looked like this or like this, either of these pictures you would call it semi-stable or a node, but there aren't any of those in this picture here, so we'll just get rid of those. All right, here's a differential equation. Let's find the homogeneous solution first. This is when you convert this this left guy to a polynomial, so lambda squared plus 3 times lambda, and there's no constant, or there's no like multiple of y here. Then we factor this. Their solutions would be 0 and -3. So y sub c would be equal to c1 e to the 0x plus c2 e to the -3x. Simplify that as just c1 plus c2 e to the -3x. And hopefully this makes sense too. So if I were to do just like a constant, if I were to do y double prime plus y prime, those are both going to be 0 for just a constant thing. And then if you were to do e to the -3x, plug that into y prime, you get 3 times -3 e to the -3x, so -9. And if you were to do y double prime, you get -3 times -3 by doing like the just derivative twice, so +9 e to the -3x, so those would cancel, yada yada. Okay, so this is the homogeneous solution, or the general solution to the homogeneous part, sometimes called the complementary solution. All right, let's find the particular solution to the differential equation using something that we actually learned. We'll just do the guess and check method. Yeah, again, don't worry about this. We didn't learn that, but we did learn how to do this using the guess and check sort of thing. All right, so that would be when we say y sub p is equal to ax squared plus bx plus c. And we're doing that because that is the form that this has. This is like just a quadratic, so you should guess that y sub p is also going to be a quadratic, right? If this was like sine of x, then you would guess that y sub p would be like a sine of x plus b cosine of x or something like that. So yp prime is 2ax plus b. Yp double prime is just 2a. So we get y double prime plus 3y prime equals 6x squared minus 5x plus 9. This becomes 2a plus 2ax plus b times 3. So 6ax plus 3b all right, let's see. So we can say 6a, so this is the x term. This has to equal -5. And 2a plus 3b has to equal 9, because these make up the constant term. So a is equal to -5/6. So this says -10/6 plus 3b equals 9. So 3b is equal to 9 plus 10/6. That's terrible. 9/6 is 54/6. So b would be 64/6 divided by 3. So that b divided by 18. So that's our b. You could simplify if you care. I don't. But y sub p would be equal to then -5/6. Wait, hold on, something's fishy. What happened to the c? All right, let me just write down what I think it's supposed to be. X squared plus 64/18x. And then what's up with the c? I guess we just pick c to be 0, right? Yeah, I guess we just pick c to be 0, and that's fine. I think that should still satisfy the differential equation. Oh, yeah, okay. Yeah, because, yeah, this is a constant up here, so if we were to, like, have this be, like, a +5, like, that could, like, technically, like, be absorbed into the homogeneous solution. So, yeah, this is actually fine. So this would be our particular solution. And so the general solution would be y equals -5/6x squared plus 64/18x plus our complementary solution, c1 plus c2 e to the -3x. Yeah, so if you had like a plus c right here, then you'd have like plus c plus c1, and you would just like want to absorb those into each other. But particular, you're only looking for a single solution. Like you don't want like a bunch of solutions or anything. It's weird. All right. E to the 2x is a solution of the given differential equation. Use reduction of order to find a second solution. Y sub 2. Oh my god, they didn't give the reduction of order formula. How dare they? I don't know the reduction of order formula. Okay, it's y1 times the integral of e to the integral of -4 dx all over y1 squared dx. Okay, this is what I think it is. I'm just gonna go off of this. All right, this might be just like totally wrong. Okay, y1 is e to the 2x, e to the integral of -4, that's e to the -4x, all over y1 squared, which is e to the 2x squared, so that's just e to the 4x. Oh, this is probably supposed to be negative. Yeah, so it should be 4x. Yeah, okay. Yeah, you make this thing negative, right? That's part of the formula. And so this is e to the 2x times the integral of just 1 dx, and that is just e to the 2x times x. So e to the 2x times x should be our second solution. I am going to go double check that formula. I'm going to double check it on my computer. One second. I'm like pretty sure I got it, but yeah, okay, yeah, I got it. Okay, cool. All right, what's the general solution of the differential equation? That is just c1 e to the 2x plus c2 e to the 2x times x. We're at a fourth order linear non-homogeneous differential equation. So it's going to be, needs to have like a fourth derivative of y. Let's throw in a y prime minus, I could do x times y, and this is equal to x squared to make it non-homogeneous. I didn't really have to have this here, or even this here, like that all didn't need to be there. But yeah, this is linear. If I wanted something that's non-linear, that would be like, okay, so this is first order, so I'll do like y prime plus, if I want it to be non-linear, I would do like sine of y. And if it's homogeneous, then this equals 0. We didn't cover this. Use Laplace transforms to solve the following IVP. Wonderful. All right. So we do L of the left-hand side equals L of the right-hand side. The left-hand side, L of y double prime is s squared y of s minus s y of 0 minus minus y prime of 0 plus 2 L of y prime, which is y of s minus, sorry, this should be s y of s minus y of 0 and then plus 10, which is capital Y of s. This is equal to L of e to the t, negative t, which is just 1 over s plus 1. Okay. Plug in our initial conditions. Y of 0 is 1. Y prime of 0 is negative 1, so that makes this plus 1. Plus 2s y of s minus 2 y of 0, which is 1. Plus 10 y of s. Okay, let's pull out all the y of s terms. We get s squared plus 2s plus 10, and that's minus s minus 1, combining this and this. So I'm just doing some algebraic cleanup here. So we get 1 over s plus 1 plus s plus 1. And then I'm going to divide all of this by 1 over s squared plus 2s plus 10. we get 1 over s plus 1 times s squared plus 2s plus 10, and plus s plus 1 over s squared plus 2s plus 10. All right, we're going to do completing the square on s squared plus 2s plus 10. So that is s squared plus 2s plus 4, or sorry, not plus 4, plus 1, because this factors as s plus 1 squared. And then I'll keep that, so like I'm pulling off like a 1 from the 10, so it separates into 1 and 9. Which you can then factor. I'll do that on this one as well. So this factors as s plus 1 squared plus 9, which is 3 squared. So this is s plus 1 squared plus 3 squared. We're going to have to do completing or partial fractions on the other thing. Okay, let's do that over here. So 1 over s plus 1 times s squared plus 2s plus 10 is equal to a over s plus 1 plus b s plus c over s squared plus 2s plus 10. And I'm reverting back to this thing over here because it's just gonna, we're just gonna expand everything out anyway. Multiply everything out. Get as squared plus 2as plus 10a plus bs squared plus cs plus bs plus c. What are the equations we get from this? We get a plus b give us 0. What about the s terms? 2as plus c plus b. 2a plus b plus c, that equals 0. Took care of those. 10a plus c equals 0. All right. Okay, so b is negative a, and c is negative 10a. So let's throw that information into this equation. So this becomes 2a plus b, which is negative a, plus c, which is negative 10a. So this is 2 minus 11, or negative 9a. Oh wait, really? It's just equals 0? Oh, no, I screwed up. What did I screw up? Something has to equal 1. Yeah, what equals 1? The constant terms. Where are the constant terms? Constant term. Yeah, constant terms equal 1. Those equal 1. So C is 1 minus 10a. So this is 1 minus 9a equals 0. So a is 1 over 9. B is negative 1 over 9. And C is 1 minus 10a. So 1 minus 10 over 9, which is just negative 1 over 9. So that's our A, B, and C. So this should equal, a is 1 over 9, so 1/9 over s plus 1, plus, and I'll just keep this as, okay, b and c are both negative, so I can say, just factor out a negative 1/9 from all of that, and be 1 over s squared plus 2s plus 10. Okay, if I were to do that too, and if I were to go backwards from this, s squared plus 2s plus 10 minus s plus 1 seems fishy. Yeah, I think I messed something up. I'm not restarting this video. I'm just gonna figure out what went wrong. Alright, so this should be a over s plus 1 plus bs plus c over s squared plus 2s plus 10. If I multiply this out, a times s squared plus 2s plus 10, and bs plus c times s plus 1. So this is as squared plus 2as plus 10a. And then this is bs squared plus cs plus bs plus c. So this seems good. S squared terms have to sum to 0, so a and b equals 0. The s terms, which is 2a plus c plus b, there are no s's over here, so that has to equal 0. And constant terms is just c and 10a. That equals 1. So c is 1 minus 10a. B is negative a, 2a minus a, plus c, which is 1 minus 10a. That equals 0. This is a. Is it right? Okay. So 1 over 9 over s plus 1 plus. Okay. I think it was. Okay, yeah, I think this is fine. This is negative 1 over 9 times s minus 1 over 9 over s squared plus 2s plus 10. Okay, I think this is fine. So you get s squared plus 2s plus 10 minus, this just becomes s plus 1 squared all over your denominator. And so this becomes s squared plus 2s plus 10 minus s squared plus 2s plus 1. So this all cancels to leave you just a 9 over your denominator, and then the 9 cancels with the 1/9. So yeah, okay, I'm happy with this. Cool. Sorry about that. All right, so everything's good. So this thing over here splits up like so. So 1/9 times 1 over s plus 1 minus 1/9 times 1 over s squared plus 2s plus 10, which we're going to complete the square for that anyway. plus s plus 1 over s plus 1 squared plus 3 squared. So y of t is L inverse of all of this. What's L inverse of 1 over 9 times 1 over s plus 1? Well, the 1/9 just comes along. And this would be e to the negative t. Okay. Minus 1/9. All right, here's where translation theorems start happening. Let's go to the thing. Yes, go here. Okay. I'm just gonna get rid of this if. Okay, what were we trying to figure out? Trying to figure out this stuff. Let's just bring that over to the formula sheet. You will have a formula sheet for the final. Okay, L inverse of, okay, so we have a translation thing for both of them, really. And then, stop it. Right. So L inverse of this thing, this is e to the negative t times, let's keep the 1/9 there, times L inverse of 1 over s squared plus 3 squared. And then this is e to the negative t times L inverse of s over s squared plus 3 squared. So L inverse of s squared, 1 over s squared plus 3 squared. That's almost sine of kt, but there's like, it's missing a 3. So I have to divide by an extra 3 to compensate. And then you would get sine of 3t. And then plus e to the negative t times, this would just be cosine of 3t. That's just straight up. Okay, let's copy that. Nope, not convert. Copy that and let's bring it back. This would be our y of t. All right, cool. Last thing, I don't want to do this. All right, 1, 1, negative 2, 3. Okay, so, oh, it's just general solution. So that'll be easy. A minus lambda I, take the determinant, 1 minus lambda, 1, negative 2, 3 minus lambda, 1 minus lambda times 3 minus lambda, and then subtract off product diagonals. Double negative gives you positive 2, so this is lambda squared, minus 3 lambda, minus, okay, so minus 4 lambda, plus 3, plus 2, combines to plus 5, so lambda, oh. No, this is probably fine. It's probably just a complex eigenvalue thing. Okay, so lambda squared minus 4 lambda, and then plus 3 plus 2, so that is plus 5. Okay, so lambda is equal to negative b plus or minus b squared minus 4ac all over 2a. So this is 2 plus or minus the square root of 4, negative 4 over 2. So this is square root of 4, or I times the square root of 4, so I times 2 divided by 2, just get that. Okay, so let's do, so those are 2 eigenvalues. Oops. So we'll do A minus 2 plus I times the identity matrix, which is equal to 1 minus 2 plus I, 1, negative 2, and 3 minus 2 plus I. We'll reduce this. We get 1 minus 2 is negative 1 minus I, and then 1 plus I. This is where you want to multiply by the conjugate. So let's multiply row 1 by the conjugate, which would be negative 1 plus I. Negative 1 minus I times negative 1 plus I is negative 1 squared minus I squared. I squared is negative 1, so minus negative 1, that's plus 1. And then negative 1 plus I. What's wrong? Yeah, something messed up because these are not multiples of each other. Oh, this was supposed to be minus. Yeah, that was supposed to be minus. So there should be minus as well. So this is, in fact, so 2, negative 1 plus I, and negative 2, and 1 minus I. So these rows are opposites of each other. So let's do just do row 1 added to row 2. Just get that. So this tells us that 2x plus negative 1 plus I y equals 0. So we can pick our vector v to be, well, you make your x value just negative 1 plus I, and your y value to be 2, and it'll be satisfied. Split this up into the real part plus the imaginary part. You get this. This is your u, this is your w, and then we're just looking for the general solution. Waste a lot of space here. All right, what's the general solution? So I think it's like e to the at, so e to the 2t times negative 1, 2, gosh. Formulas. Aren't you glad that I am giving you the formulas for the test? You must be so happy. Okay. Cosine of bt, and b is just 1, minus w, which is 1, 0, sine of t. Okay, and that's our x1, so I should put c1 here, plus c2, e to the 2t, times 1, 0, cosine of t, plus negative 1, 2, sine of t. All right, and we are done. Cool. There's a good joke at the bottom too. This exam, I'm pretty sure this exam was written by my friend Paula, who is obsessed with puns. Paula loves puns. That's one thing I know about. Okay.